Welcome. Today we're going to dive into a skill that is absolutely critical for every AI engineer, mastering prompt efficiency. And let me be clear, this isn't just some minor optimization. This is a core discipline that directly impacts the cost, the speed, and the accuracy of any production AI system you will ever build. So here's how we're going to break it down. We'll start with what I call the token tax problem, just to make sure we're all on the same page with the fundamentals. Then we'll look at some simple but really powerful solutions you can start using today. After that, we'll get into the more advanced stuff, compression techniques for large-scale systems, and finally, we'll tie it all together with some practical insights for your next system design interview.
Okay, first things first. We need to get a handle on this core challenge that every single large-scale AI system is up against. I call it the token tax, and understanding this is absolutely fundamental to building efficient, cost-effective applications.
So here's the thing you gotta get. Language models, they don't see words the way we do. They operate on tokens. And as you can see, a token might be a whole word like apple or just a piece of a word like ing. Every single one of these is a unit of computation, and each one has a direct impact on your system's performance.
And when your prompts are inefficient, it's not just one problem. It's a domino effect. First, you're paying more, right? Because you pay per token. Second, your app gets slower. That's latency. And third, and this is super important, longer prompts can actually make your model less accurate by introducing noise. Put it all together, and you've got a really poor user experience.
So, how do we fight this token tax? Well, the most powerful tool we have isn't some super complex algorithm. It's actually something much simpler. The principle of writing with clarity and precision.
You know, it's funny, but the writer Ernest Hemingway really nailed the core idea here. His whole philosophy was built on minimalism. Every word had to earn its place. And that is exactly the mindset we need for effective prompt engineering. The question isn't what you can add, but what you can take away without losing the core meaning.
Let's look at this side by side. It makes it really clear. The verbose prompt on the left is just full of what we engineers call prompt noise. Words like please or in detail. They add tokens, they add cost, but they add zero instructional value. The concise prompt, on the other hand, is a direct, clean command. It's cheaper, it's faster, and it gives the model a much clearer target.
So think of this as your practical playbook, the Hemingway method for prompts. It's just like refactoring your code, but for your language. Use simple words. Be absolutely ruthless in cutting out words that don't add critical meaning. Give direct instructions, and force yourself to be brief. This kind of discipline brings clarity, and it directly slashes your token count and your costs.
All right, so we've got the fundamentals down. Manual prompt design is your starting point. But now let's get into the more advanced stuff, the systematic engineering solutions. We're going to talk about system-level architectures for compressing prompts automatically.
Now, when we talk about prompt compression, it really splits into two big camps. You've got hard prompt methods on one side. These work with normal text using algorithms to filter or rephrase things to cut down on tokens. But then you have soft prompt methods, which are a whole different beast. These actually translate the meaning of your prompt into a compressed series of numbers, embeddings. They aren't readable by us, but they're an incredibly efficient way to give instructions to the model.
This chart here, from a great research paper, really lays out the whole landscape for us. See how it branches off? On the hard prompt side, you've got things like filtering and paraphrasing. On the soft prompt side, the solutions get more architectural, right? You're dealing with different model types. The main point here is that prompt efficiency is way more than just a writing exercise. It's a formal field of systems research with real engineering solutions.
Now, this is where it gets really interesting from a systems perspective. These are actual architectures for soft prompt compression. Take the GIST model, for example. It uses a fine-tuned language model to basically squish a long prompt down into a few special GIST tokens. Other methods, like autocompressor, go even deeper and compress information right into the model's key value cache. That's like its short-term memory. Each one of these is a different engineering trade-off. GIST might give you amazing compression, but it takes a ton of resources to fine-tune, which might not work for your team.
Okay, let's switch gears. How do you actually talk about this stuff in a job interview? Because connecting the theory to real-world impact, well, that's what gets you hired.
You're going to get asked this. I can almost guarantee it. It's a classic, fundamental concept, so you need to have a crisp, confident answer ready to go.
The key here is to link being short with being effective. Minimalism isn't just about using fewer words. It's about efficiency. The goal is to maximize the signal, the core instruction, while minimizing all of the noise. From an engineering view, you want maximum utility for minimum token cost.
And this is the natural follow-up, right? If you can clearly define prompt noise, it shows you've really thought about the problem on a deeper level.
Your answer here is about the trade-off. Noise is basically any token that adds cost and might even confuse the model without giving it any useful information to do its job better. This means things like filler words, redundant phrases, or details that are just irrelevant to the task.
Now, this is the kind of question that separates a junior engineer from a senior one. They're not just asking about tokens, they're asking about business impact and large-scale system design.
A great answer has to connect the tech to the business outcomes. First, clarity. That leads to better model accuracy. Second, time savings. That means lower latency for the user. Third, consistency. Your system becomes more reliable and predictable. And finally, the one that every manager cares about, cost reduction. Fewer tokens directly cuts your operational spending. Showing you understand that is crucial.
So let's wrap this all up. If you remember nothing else, remember these 4 things. 1. Every single token is a tax on your system. It costs you latency, money, and accuracy. 2. Your best weapon is simplicity. Always start there. 3. For the big, complex problems, know that advanced tools like prompt compression exist. And 4. In an interview, you have to be able to talk about the trade-offs between all these different approaches.
And I'll leave you with a challenge, a real system design question to chew on. How would you architect a system to automatically find and fix this token tax problem across an entire company's applications? Think about that for a minute. You'd need logging, an analysis pipeline, maybe some automated refactoring. It's a real-world engineering problem.
If you found this deep dive into a real engineering problem valuable, then you should definitely subscribe to Naveen Tech Hub. We break down AI architectures, agents, and the practical concepts you need to know to build real-world, production-grade systems. Thank you for your time.